Hello students, I Hitesh Prajapati, Assistant Professor in Mechanical Engineering Department of Aditya Silva Institute of Technology. Once again, I welcome you all in my video lecture 3. So in this lecture, we will discuss about this detailed working of the four-stroke diesel engine. From that working, we will try to plot theoretical PV diagram, actual PV diagram, theoretical valve timing diagram and actual valve timing diagram. Four-stroke diesel engine. So in this figure, you can see the working and construction of four-stroke diesel engine. The diesel engine work on this principle of diesel cycle and also called constant pressure heat addition cycle. Uh, Later on, we will discuss how this cycle is said to be a constant pressure heat addition cycle. The four-stroke diesel engine also consists of same as petrol, suction stroke, compression stroke, power, working or expansion stroke and exhaust stroke. The basic construction of the four-stroke diesel engine is as the same as the four-stroke petrol engine, except instead of spark plug, we have the fuel injector mounted on this place of spark plug. A fuel pump is supplied the diesel fuel to the injector at high pressure. So students, first stroke, suction stroke. So during this stroke, the inlet valve is open and exhaust valve is closed condition. The pressure inside the cylinder will be the atmospheric pressure. As the piston move from top dead center means TDC to PDC, the volume in the cylinder is increased. Simultaneously, the pressure inside the cylinder is decreased. And this creates the pressure difference between the inside of the cylinder and outside of the cylinder. So due to this pressure of difference, the air from the air filter is going inside the cylinder, and this stroke is represented by again 1 to 2 line in this PV diagram. You can see in the subsequent slide. So end of this stroke, the cylinder will be full of air filled and inlet valve will be closed. Second stroke, the compression stroke. So during this stroke, the both means inlet and exhaust valve are remain closed condition. The piston will be moved from bottom dead center to top dead center, and at this stroke we perform the air in the cylinder will be compressed So the pressure and temperature of the air is increased. The process of this compression is shown in the figure 1 to 2 line in this theoretical PO diagram. The compression ratio of this engine means diesel engine the higher than the petrol engine. So due to the higher compression ratio, the air will attain the higher temperature than the self-ignition temperature of the diesel fuel. Near the end of this stroke, the metered quantity of fuel, मतलब कि definite quantity of fuel will be injected into the cylinder. So as the diesel fuel particle come contact with the high pressure and temporized air, so it will ignited diesel fuel, and this type of engine is also called the compression ignition engine. Shortly, you can say the CI engine. The constant pressure combustion process is represented by the horizontal line 2 to 3 line in this PV diagram. Third stroke students, you can say the power working or expansion stroke. So during this stroke, both the valve means inlet and exhaust valve are remain closed condition. The piston will be moved from TDC to BDC. The fuel injection start nearly end of this compression stroke, but the rate of injection is such that the combustion maintain the constant pressure. The constant pressure expansion with simultaneously combustion is represented by the horizontal line 3 to 4 line on this PV diagram. The piston is forced further during the remaining part of this stroke due to the expansion of the burn gases. The engine produces the mechanical power during this stroke, so that is why it is called as a working stroke or expansion stroke. So at this piston is moved from TDC to BDC, the pressure of the hot gases gradually decreases and the volume is increases. This present is curve 3 to 4 line in this PV diagram. And last stroke students, we have the exhaust stroke students. So during this stroke, the exhaust valve open and inlet valve is closed condition. So the piston will move from BDC to TDC, means bottom dead center to top dead center. And during this motion, the piston is pushing the all these burn gases, मतलब कि combustion products which is produced by the combustion of the fuel inside the cylinder is out of the cylinder at constant pressure, and this process is shown in figure during 1 to 0 line in this PV diagram. In this slide, students, you can observe this theoretical PV diagram and while timing diagram. As I said to earlier, the 5 to 1 is nothing but the suction process. During the suction process, the air inside the cylinder will inducted. During 1 to 2 process, so 1 to 2 process is nothing but this indicated the compression process. So during this process, the air inside the cylinder being compressed by closing of the both the valves, and at the end of this compression stroke, the large amount of pressure and temperature is being developed, and the pressure which is developed at the end of the compression stroke is higher than this ignition temperature of the diesel. So which is indicated 1 to 2 line. During 2 to 3 line, the fuel diesel is injected inside this engine cylinder in a small droplet. So that's why it catches the heat, ignition temperature or ignition heat from this compressed air. So that's why it get ignited inside the cylinder, and this process is carried out at the constant pressure. So you can observe this line 2 to 3 line is a horizontal line. Next, 3 to 4 line is indicated the working expansion stroke which is carried out 3 to 4 line. At the end of this expansion stroke, uh, the heat rejection process will be carried out at the constant volume. So that's why the 4 to 1 line is a vertical line in, as you can see in the PV diagram, And lastly, 1 to 5 is nothing but this exhaust stroke. So during this stroke, the piston is moved from BDC to TDC. By opening up this exhaust valve, all the burn gases will be sweeping out to this atmosphere, as you can see in the PV diagram. So that's right figure is nothing but the theoretical valve timing diagram. So in theoretical, we have assumed that all these stroke will be occurred through the 180 degree of the crank revolution. So the exactly it has the two revolution of the crankshaft, as you can see figure. So at TDC you can observe the inlet valve open, shortly it written as a IVO, and at the exactly BDC position you can observe the IVC. It means inlet valve is closed condition. मतलब कि IVO to IVC it occurs the exactly 180 degree crank revolution. Further 180 crank revolution, it is indicated the compression process, as you can see the figure, and at the TDC, at the end of the compression process, the fuel injector will inject this diesel, atomize the diesel, so that's why the combustion process will occur. So further 180 degree TDC to BDC, you can see the expansion process, and further the exhaust valve is open, and exactly at the TDC the exhaust valve is closed condition. मतलब कि it whole working cycle is indicated by two crank revolution of this crank rotation. So this is what about this theoretical PV diagram and valve timing diagram of the four-stroke diesel engine. So during the working of this four-stroke diesel engine, we have to again assume certain assumptions. Uh, as you can see in this PPT. First assumption is that the suction and exhaust process take place at the atmospheric pressure. So as we have indicated in the PV diagram, the horizontal line 5 to 1 or 1 to 5, as you say already seen. Second assumption is that the suction and exhaust process take place through the 180 degree of the crank revolution. Same way, the expansion and compression process take place through the 180 degree of the crank rotation. Means already we have seen this theoretical valve timing diagram. The each stroke will be occur 180 degree revolution. So whole working cycle is two crank rotation, right? It means each stroke will be operated through the 1 degree uh, rotation of the crank rotation only. Second, इसके बाद next assumption is that the both expansion and compression process are isentropically, means the entropy will remain constant in this process. Next assumption is what? At the end of the compression stroke, the combustion will take place instantaneously at constant pressure. It means the sudden combustion of this fuel will be taking place. Last assumption is that the pressure suddenly fall to the atmospheric pressure at the end of expansion stroke. So during the heat release process, the pressure which is built up in this during this combustion of this process is suddenly dropped to this atmospheric pressure. So this is what about this assumption of this uh, four-stroke diesel engine. But when you study about this actual condition, so it's totally different than the theoretical assumptions. So as I said, students earlier, the actual scenario or actual condition is totally different than the ideal one. So first ideal condition or actual condition, the suction process possible only and only the pressure inside the cylinder is below the atmospheric pressure. So in previous lecture, as I also mentioned, at the same pressure between these two systems, the fluid flow is never be occur, right? So for the fluid flow, it has to be something pressure difference. So that's why. So if suction is created, uh, then but obviously the pressure inside the cylinder is very lower than this atmospheric pressure. Same way, if the at the end of this combustion, the exhaust pressure and the atmospheric pressure will be the same. The exhaust pressure, exhaust gas will be never be sweeping out to this atmosphere. So there must be at the end of this combustion process, the exhaust gases pressure will be must be higher than the atmospheric pressure. So smoothly the uh, all this one gas is slipping out to this atmosphere. So that is what the second condition. And third, the expansion and compression do not follow the any isentropical law. So as there will be always the heat exchange during this all these four stroke. Uh, for the isentropic process, there must be a heat will be uh, heat interaction never be there. Then and then in this condition, the isentropic process will be carried out. But during this working of this IC engine or any of this four-stroke petrol or diesel engine, there must be a heat interaction will be the atmosphere and this IC engine. So that's why it never carried out the isentropically. Next is the constant pressure combustion not possible because uh, it takes some time and some time in terms of some crank rotation for completed. So therefore the actual pressure is less than the theoretical. Last assumption, same way, the constant heat rejection is never possible because its sudden released after the opening of the exhaust valve is not possible and it takes place with the some crank revolution. So combustion, heat supply and heat rejection process, it requires some time. So never be in instantaneous process will occur in nature. So that is what is actual scenario in this engine. So here the actual PV diagram of this four-stroke diesel engine as you can see in this slide. So in the PV diagram of theoretically we have plotted. So in that diagram we only the one loop is uh, generated. It is from in clockwise direction. While you as you can see in this slide, there will be a two loop or two cycle is created, upper one and lower one as you can see in the figure. So upper one I consider as a positive because it loop rotate in a clockwise direction, and as you can see in the thermodynamics, when the loop is rotated in a clockwise direction, so it produces the power. So sometimes it's said to be a power developing loop, and while the lower loop, as you can see, the I have indicated by minus loop. So because it rotated in an anti-clockwise direction, as you can see in the figure. So when it's rotated in an anti-clockwise direction, so it always consumes the work. So by considering the net amount of work developed by this engine, it will be a difference between the two loops. So that's why I put the difference of loop, I mean positive loop minus negative loop. Secondly, students, the negative loop sometimes is said to be a pumping loop because so exhaust is occur the above the atmospheric pressure line, and 0 to 1 I mean suction is created the below the atmospheric pressure line. So due to this pressure difference it's create some pump kind of operation. So sometimes it's said to be a pumping loop. So this is what about this actual PV diagram of four-stroke petrol engine, diesel engine, sorry. Now students look at this PPT. So this PPT or this figure is indicate this while timing diagram for this four-stroke diesel engine for the low speed and high speed engine as you can see in figure. So the actual while timing diagram for the four-stroke diesel in this figure you can see uh, the opening of fuel valve before the TDC is necessary for the better evaporation and the mixing of the fuel, and as there is always a lag between the ignition and uh, supply of fuel, and it is always necessary to supply the fuel little earlier. So in case of the diesel engine, the valve overlapping is provided sufficiently 45 degree compared to with the petrol engine is somewhat about the 13 degree about. So more overlapping is not available in the petrol engine because the mixture of the air and fuel pass out these exhaust gases, matlab ki the charge will be diluted otherwise you can say, and highly uneconomical. So sometimes it's the charge is lost to these exhaust gases might be happen. So this tension does not arise in this case of diesel engine because only air during the suction stroke will be getting the inside. So while timing diagram engine have to be adjusted depending upon the speed of this engine. The typical timing are follows. So as you can see in figure, my low speed engine, you can see the inlet valve open, matlab ki indicated by IVO, and which is about to I think 25 degree before this TDC. So then the inlet valve close, you can see in the figure IVC, it is indicated in this figure, and it is around 35 degree after the TDC. So these you can observe that the suction stroke is almost about 240 degree instead of 180 degrees. This is due to the more amount of air getting the inside the uh, engine cylinder, so that's why it's increased the volumetric efficiency and better combustion and better output of the engine. So injection start, you can see in this figure, almost it is 12 degree before this TDC and 16 degree after TDC as well. So 16 plus 12, almost 28 to 30 degree, the fuel valve is open. So during this, the it inject the diesel, I mean it atomize the diesel in a small droplet, so that's why it increase the surface area. So that's why it absorb properly heat and start the combustion. So you can observe this in figure. If we talk about this exhaust valve, so you may observe that the exhaust valve is exhaust valve open 35 degree before this BDC, मतलब कि early opening of this exhaust valve you may see, and it closed after 20 degree TDC as well. So see, the exhaust valve is around 235 degree, मतलब कि longer this exhaust valve, as you can see in the figure, and right side figure is indicating the high speed engine while timing diagram for the 4-stroke diesel engine. So little bit plus or minus degree will be there due to this better operation and optimization of this performance. So this is what about this while timing diagram of the 4-stroke diesel engine.